Hello everyone. We will present our assessment about forecasting. We will focus on two basic methods, the least squares method and the moving average. My name is Song Lingbo, and my group members are Hired and Limisai. This slide shows the outline of our presentation. First, we explain what forecasting is and give some examples from different fields. Then we introduce the least squares method and the moving average, and show the simple examples for each method. At the end, we will have a short conclusion. Forecasting means using past and present data to estimate the future. For example, companies forecast future sales, project managers forecast project duration, and weather stations forecast rain and temperature in operations and control. Forecasting is important because it helps us plan resource, time, and cost better, and reduce the risks. Here are some examples of forecasting in different fields. In business, companies forecast sales, revenues, and explains to plan stock and staff. In project management, managers forecast time and cost to see if there will be delays or overruns. In weather, forecasting is used to predict temperature, rain, and wind in the next few days. This slide is about the least squares method. We have many data points. For example, monthly sales, and we want to draw one best straight line through them. The method finds a line that makes the total squared distance between the points and the lines as small as possible. Then we can use this line to show the trend and to predict future values. For this slide is about the advantages and disadvantages of the least squares method. Simply speaking, the advantages is that the method is easy to understand and it gives a clear trended line that we can use for forecasting. But there are also disadvantages. It only works well when the relationship is almost linear, and it is sensitive to strange data points, sudden big changes. So the prediction may not be very.
Hello everybody, my name is Mohammed. I'm the second member in the group assignment for the operation planning and control. So let's continue with our method, last square method formulation. To formulate the last squares, we need three main equations. As you see here, there's three equations, and for the first one, y equal to mx plus b. So y here is referred to a dependent variable like time or weekly, yearly, daily, or something like that. For the x in the equation also one, it's referred to the price, to the rent, so on. Also, for the slope of the last square method that we needed in the second equation, and b is the y-intercept. So to implement last square method, we need to follow some steps. First, we need to collect the data and define variable. It's really important at the beginning to know what's your objective and what do you want to forecast, what do you want to predict. Then gather relevant data points that show the relationship between the variables you want to analyze. Identify the dependent variable, like what you want to predict, and the independent variable, what influence it. The goal is to find the line that minimizes the goal square distance error. between each actual data point and the predicted value. Then construct an equation that models the relationship between variables. Then set up the last square equation to calculate best fit line, slope, intercept. Also, use the last square formulas to find the slope and y-intercept a, which is a of the line. The result equation is can defined by y equal a plus bx. Represent the line the best fit. The data can be used for future prediction. Let's take an example to illustrate the last square method. Here is the small company, small store that went to predict future sales. And here in the table that you see, there's table for X and Y. X here referred to the month, number of month, and Y is referred to sales, monthly sales. So let's answer the example by following the steps that we went to implement and that we already illustrate previously to solve the last square method. As we said, we need to collect and define variable, independent variable. So for an independent variable, X refer to month, dependent variable Y sales in thousand of franc. So continues with the second step to calculate and to solve our example. So in this page, we will explain how to calculate the slope B and intercept A. The first equation, which is B, and as you see in the page, this is how to solve this B. Then we need to solve A, which is Y minus B multiple X. So first, we need to solve the X dash. To solve the X dash, we need to multiple the how many months that we will use divided on the total number of the months, which is 7. Then we get 4. For the Y dash, we need to calculate the monthly sales dividing on the number of months. And we get 4 and 135.28 for Y dash and X dash. By plugging the X dash and Y dash to the equation 1, which is B, then we get a slope B. The second steps and to upload this B and X dash Y dash to get A. And as you see here, the final equation for the best fit line is equal Y 71.29 plus 16x. Then in the last step, we solve graphically the data and the base fit time. By using Minitab app, we upload the equation and the data that we have, and we get this graph. And you see here the distribution of the point around the line. Then let's take an example, month 8. We already done with the 7 months. Now we want to predict for the future, for the month 8. Just we upload the month that we went, like month 8 or different like 10, 15, 20, whatever we want. Just upload it to the main equation. Then we get the number.
The next forecasting method is moving average, where moving average is a commonly used time series forecasting technique. It is especially useful when we want to analyze a variable like sales, attendees, returns, and so on, across several consecutive periods, especially if there are no other data that is provided. So we need to use moving average to predict the value of the next period. It's often more preferable to use historical data so that we can like find the average, the mean that we will use to forecast. Moving average compensates for short-term fluctuation, and usually moving average predict the value of the next period by using the average or mean the value of n period of time. There are a few advantages and limitations of moving average. The first advantage is that it is easy and simple to understand with very simple calculation. The second one, it is effective for smoothing, helps to smooth out random and short-term fluctuations, and also it is easier to identify trends. Somehow, there are also a few limitations. The first one is that because it is based on historical data, they can lag or they can fall behind the actual trend. Second one, it is not responsive to change. The third one, it requires sufficient data, especially if we want to predict a longer period of time, so we need longer averaging period, and also requiring more historical data. The fourth one is the choice of period is critical, because if we choose the period too short, then the prediction will not be smooth enough. But if the period is too long, then it will be too slow to react to any changes. The moving average formula is the following. Basically, we add we sum the data points over a specific period of data that we already set, and then divide the number of periods. We find the mean within the period of data that we set. Okay. So these are the steps to implement the moving average. First one, we collect the time series data, uh, whether it is weekly, daily, monthly, or annually. And then the second step, we choose the order, how many past periods that we will include in the average. Usually we use 3, 4, or 12 periods to make it easier. Step 3, apply the moving average formula, the one that we already discussed previously. And step 4, create the moving average table. Step 5, plot the moving average. Next, we forecast the next value, and then finally, we interpret the result. This is an example for a moving average. A retail shop recorded its weekly demand for a product over 10 weeks, shown below. Using a 3-week moving average, calculate 1. The 3-week moving average for weeks 4 to 10, 2. The forecast for week 11, and 3. Short explanation of what moving average shows in forecasting. So this is the table for the forecasting of week 4 to 10. Here we can see that the period is 3. We are using the the 3 weeks time period. So we will use every 3 weeks to forecast the next week. For example, to forecast week 4, we use the historical data from week 3, 2, and 1. So it is 250 plus 270 plus 260, and then divided by 3, we get 260. To get week 5, we use the week 4, week 3, and week 2. So we add 270 with 260 and 290. We divide it by 3, then we get 273.3, and so on and so forth until week 10. Moving average, they smooth fluctuation in the data by averaging recent value, and this helps to reveal the underlying trend and also reduce the impact of random variation. These are the references that we used in our presentation, and thank you very much.